Hi everyone. Today we can go through question 2 of November paper 2016. Question 2 is related to the first section of organic chemistry, which is the structures of organic compounds. In this question, we have from A to F 6 different compounds with either their structural formula or IUPAC names are provided. And the questions follows those 6 structures. The letters A to F in the table below represent 6 organic compounds. Let us quickly identify what compounds we have in each option, and then we can answer the rest of the question. The first molecule, as you can see, this compound has a double bond that makes this molecule to be an alkene. Let me change the color of my pen. That will be good. The compound B says ethyl ethanoate. As you see, it ends with OH suffix. So this compound is an ester. Compound T is saying polyethylene. This is part of a polymer. Polymers are not in the syllabus anymore, so we don't need to answer this one, but it is basically a polymer. And then compound E, as you see, has a carbonyl group linked to an oxygen, but there is no hydrogen on the other side. So that this is an ester, not a carboxylic acid, but this one is an ester. And the next one is C double bonded oxygen, and there is an OH on the other side that makes it a carboxyl group. So compound F is a carboxylic acid. Write down the letter that represents the following. The first question, a hydrocarbon. Remember, hydrocarbons are the organic compounds which are made of only carbon and hydrogen atoms. We have 3 types of hydrocarbons, alkane, alkene, and the alkyne. And when we look at this table, alkane is a hydrocarbon, alkene is a hydrocarbon, and alkane is a hydrocarbon. So that you can say A or C. These are 2 options. You can write either one. A functional isomer of compound F. Functional isomers are the compounds with same molecular formula but different functional group. F is a carboxylic acid. The functional isomer of a carboxylic acid is an ester. So we need to look at the options, which one is ester. Compound P and E are esters. Then to decide which one it is, we need to count the number of atoms. In compound F, I have 1, 2, 3, 4 carbon atoms. But in compound E, I have 1, 2, 3. So E cannot be an isomer, a functional isomer of compound F. But when we look at compound P, ethyl means you have 2 carbons, and ethanoate has 2 more carbons. In total, we have 4 carbons. So the correct answer is B. B is a functional isomer of compound F. 2.1.3. A compound which belongs to the same homologous series as compound B. Compound B is an ester, and compound E is also ester, so it belongs to the same homologous series. A plastic. Plastics are not part of the syllabus anymore. It is removed, but basically a polyethylene is a plastic. Polymers are the plastic, or plastics are the polymer. Write down the structural formula of each of the following compounds C. All right, let me Put the video off. And compound C, I'll choose a different color. So for compound C, the structural formula. When we look at compound C, it has 5 carbon atoms, pentane. That indicates we have 5 carbon atoms. On the third carbon, we have a methyl group. On the second and third carbons, we have 2 bromine atoms. So let us start with the pentane. Pentane means 5 carbons, so I write 5 carbon and I bond them with a single bond, 4 and 5. We will use only single bonds as it is pentane. On the second carbon, that is my second carbon, there is a bromine. On the third carbon, I have another bromine atom. You can write it up or down, that's not matter. And I have a methyl on the third carbon as well. So here is my methyl group. I don't have any other substituents, so the rest I just need to add the hydrogen atoms. The first carbon needs 3 hydrogen atoms to be stable, to have its octet. The second one needs 1 hydrogen only. Third carbon atom has 1, 2, 3, 4 already, so it doesn't need extra bond. This one needs 2 hydrogen atoms, and the last one needs, last one needs 3 hydrogen atoms. So that is the structural formula for compound C. When we come to 2.2.2, the acid used to prepare compound B. This is also related to a bit the reactions I mentioned the other day. Compound B is an ester. Esters form when we have an alcohol and the carboxylic acid. This part of the ester comes from carboxylic acid. That part of the side chain comes from the alcohol. So to form ethanoate, we need a carboxylic acid, and this carboxylic acid must have 2 carbon atoms as it is ethanoate. So the carboxylic acid with 2 carbon atoms must be ethanoic acid. But I'm not going to write ethanoic acid because it's asking the structural formula. The structural formula of this one, let me say 2.2.2, ethanoic acid. Ethanoic acid has 2 carbon atoms. This is my functional group, the carboxyl group, and add the hydrogen atoms. Remember, you never omit the hydrogen atoms. If you omit, you're going to lose mark. The monomer used to make compound D. Compound D is a polymer, I said. You don't need to worry for these polymers, but basically it needs to be an ethene molecule. And ethene has a structure of this. Okay. But I repeat, you don't need this one. It's not in the syllabus anymore. And the last part of this question, 2.3, compound A reacts with an unknown reactant X to form 2-methyl propane. Write down the name of the reactant X, type of the reaction that takes place. We haven't covered the type of reactions or the reactions of organic compounds yet, but let me just go through it quickly. The compound A is an alkene, and here the end product is an alkane. To convert an alkene into an alkane, we need to add hydrogen atoms. So the name of the reactant X will be H2, hydrogen gas. And as we are adding hydrogen gas, this reaction can be called an addition reaction. You may also call it a hydrogenation reaction. But no need to worry about this yet. We will go through this section later on. That is all for this question. See you later.